Okay, so today's lesson is going to be on definite integrals. So, in our last video went over what the concept of what an integral is. Just do a brief review of that. So if you have a and b, you have some function that moves through here. An integral simply solves for the area underneath this curve. Okay, so by definite, what we mean is that we know the boundaries, which is this a and this b. Okay? If it's an indefinite integral, that means it can go from some infinite series. It can go from 0 to infinity or negative infinity to infinity, depending on if you have symmetry or not. That's something that will be dealt with in a later video. So, for a definite integral, you use the integral sign as your upper limit b and your lower limit a, and you solve an integral of your function, and it's with respect to x, so we're using the differential of x. So essentially what this is saying is that this piece right here kind of represents the sum from all a to b of the function f of x by some differential increment or some change in x. And what that will bring us to is it's the limit as n approaches infinity of the sum of n as I starts at 1 and goes to n of the function, which is what we just described, and then the differential. So that's the same as that. This is the same as this. And this integral sign here essentially is just a fancy form of putting all this. So I'm hoping that this is going to help you understand more of the concept of why an integral is like this. It's not just put there because it looks pretty. There's a reason for it. And in our definite integral, so whereas before, back in a previous video when we associated the approximation of the area under the curve, our change in x was b minus a divided by n. So n is going to dictate the amount of rectangles that we're going to have here that are going to be summed up. Sure enough, xi is going to equal a plus I delta x. Okay, so what we want to do is we want to express this limit in terms of the definite integral. So we have a limit as n approaches infinity. I starts at 1 and goes to n, and this is our function. Now remember that in this case, because we're using the sum, that the x is going to be some ith integer, and that's our f of x from before, times delta x. And that's going to be from 2 to 6. It's going to be a, it's going to be your b value. So, simply as before, what we're going to do is we're going to set this up in a definite integral. So, recall that we had the integral sign from a to b, f of x, d of x, and we simply just put in our limits for b and a, so that's going to be 6 and 2, and then we're just going to input what we have for the function. So this whole thing right here is going to be put into here. But because we're not doing a sum anymore, it's going to be for whatever value of x is put in. So we don't have to worry about putting a subscript of I down here. It's not necessary. Okay, and that is how you represent a limit as a definite integral.